Hi, Mr. Dossman here. Finally, really starting to get my voice back, and I'm really excited for this particular episode. It's just, yeah, calibrating here. um, Someday maybe I'll actually grab a good camera. This Logitech one served me well for a while, but uh, be nicer to have something more professional looking for OBS. Anyways, so today I thought it might be a very cool idea. I've kind of been doing tutorials up until this point, but I think it would be kind of neat to do a code review of what I have for Age of Chaos. I'm doing this during the day, so I might have some visitors. Let's go ahead and start with the build script, because there's actually a lot going on here, and right now I'm on my bitmap font. Not for branch. Alright. So what do we have going in build.py? Okay, so one thing I'm doing, and I'm probably going to take this out because I actually did find a really cool editor which I'm going to start using, one that'll let me share the palette between, so I won't need Python image library to transform 24-bit images to 8-bit images. So I'm very excited that I'll be able to pull that out. So I won't need this anymore, thank goodness. Alright, so we've seen a lot of this before in the tutorial I did to kick us off. Build code. This is what gets called if we're not running inside of a Docker container. So one thing I have here that I should probably bust out into its own build step is copying the Lua scripts over. Not just the scripts, but really anything. So this could be data files. I should probably change it from scripts to data because that's more indicative of what it is. And we have Windows to Unix transforms. What would be really nifty is if we could get Python inside of the Docker container image. So we'd only have one build code instead of build code and build Docker. Actually, I might just build Docker and just require Docker to be part of the toolchain. That sounds like my gaming keyboard just turning on. Whatever. So right now what we have here is we need to transform file paths from Windows to Unix if we're building it from Windows, which today I am. So can I hide this? No. Oh well. So again, here's our familiar Docker commands. I already explained this in part 1 of the tutorial series for building DOS games on Windows. Alright, so here's build execute. We're making the assumption that DOSBox is part of the path. If not, you might want to add that or hard code it in if you wind up using this build script yourself. By the way, Age of Chaos is open source, and I will be posting the link to it in the YouTube video when it's time for that. Let me just rearrange things here real quick. Alright, let's see, and then build images. Right now what I'm doing is I'm not copying things over, I am transforming them over. So I'm using Pillow, which is a Python library for doing image handling. and we're transforming images to make sure that they're in bitmap format with 256 colors. However, I have found an amazing program which I hope to be using instead called Graphics 2. It was originally a DOS-based image editor based on palettes for doing pixel art, but it has everything I need, everything I've been looking into, so I'm pretty excited for that. Just to kind of show off what I have for code so far, I don't really have much that's too impressive, just kind of showing off some small things as I have them working, just to demonstrate, oh hey, we got the mouse working. And up here in the corner, we're supposed to have the text that reads AOC for Age of Chaos, but that's not there yet. That's one thing I'm trying to debug through. So most other things are working pretty well though. So yeah, here's where you put in the commands you want. So I'm calling Python build.py, build docker, build images and run. So it's going to go build docker. I guess I don't need build images because it's built in, so it's not a separate process, though maybe it should be. So yeah, we don't need build images, so we'll just take that out. We'll be changing that script to just do a copy, because again, I found a program that will suit my needs. I can export the palette too, so I can import the palette and then skip the palette loading on the bitmaps. That's part of the reason I think the text isn't showing up, because it's two different bitmaps and the palettes aren't exactly the same. So in order to make that work, I might have to do some significant changing, or I could just use the new bitmap format. So let's go ahead and start with, I have a PDF. That's not going to render. We'll open it up and go through it. Chaos, there should be, here we go. And there's a link to the URL, which I will be posting a little bit later. Well, it'll be in the description. I don't know why I said a little bit later, after the video renders, I guess. So what's the story for the game? You are a mercenary warrior for hire in medieval times. You've been hired by the king to basically set the country back right. There's an evil wizard. He wants revenge or something. I don't know. It's not that clear. It doesn't have to be that clear. I mean, you can go back to the original Super Mario Brothers, and you got a turtle with some mushrooms, and that turtle kidnapped the princess. So you don't need to have a overly complicated story to have a fun game to play. So that's kind of what I'm hoping for, is that we will have a fun game to play. It's up to you to kill every last one of these bad guys and return the kingdom to its peaceful glory. So just kill stuff. Basically, if you're familiar with how MOBAs work, I kind of want to have a similar experience. You navigate with ASDW. You use your mouse to aim your attacks, left and right click for primary and secondary. You'll have some accelerator keys that will let you do different things. Just go over combat a little bit. You have your basic shield and sword. You can, augment that with stuff like bombs, arrows, magic wands, and more. We'll have items, passive buffs. So instead of being open world, it will be level based, and we'll try to have an item shop in between where you can rest, upgrade your character, change up your items, your equipment, your weapons and stuff. And it'll make a handy save point so you can save the game there. So this is the gameplay mock-up. It's kind of ugly. I just copied and pasted different sprites I found on the internet. So um, if you played something like Skyrim, you have, you know, your stamina, your health, and your magic. It's a pretty good system. I think we'll use it again here. Here's your main player, and here's kind of the cursor, kind of bound to relative to where it is from the player. We'll have it be kind of a virtual cursor, not a real cursor, so it'll be relative to where the mouse is on the screen. Kind of like it'll project that far out, and then it'll put a reticle around that. Here's some enemies. We'll have a cooldown timer or something for the attack. Here's an item, and here's some trees. I didn't want to spend a whole lot of time. This is mainly just so I can refer back to it. So the tech stack we're using, gosh, I really should have started with the PDF instead of doing the code dive. Oh well. We're using DJGPP, Windows bitmap for the image format, but I found a program that'll let me export the same palette across all the bitmaps, so that'll be nice. Using Lua for the scripting language, which I thought is kind of interesting and unique for doing a DOS game with a Lua scripting language. It actually works pretty well. Maybe if we get really fancy, we can use LuaJIT. I don't know how that'll work with DOS because I think it kind of needs a C compiler embedded. I'm not really sure how that works, but we'll play with that if speed becomes an issue. I don't think it will be. Audio is honestly one of the weaker places that I haven't spent a lot of time in. If anybody has some open source code that I can borrow for that and include in this, that would be neat. Yeah, keyboard and mouse support. I don't know if I'll have a version that won't use the mouse because it's almost 2020 and everybody should have a mouse. Even for the old computers, I think you can still buy a Comport mice off eBay. So, yeah, if you don't have a mouse or at least a touchpad, I don't know what to tell you. So you're hoping to keep the install size to 10 megs or less, somewhere between a floppy and a CD-ROM, I guess. If I could fit it on a single or maybe a couple floppies, I think that would be cool. I just don't have any computers with floppy drives on it, so I want it to be as simple as you unzip and then you run a batch file and you're in the game. So, kind of hoping I can get to the point where I can ship this on Steam inside DOSBox or something like that. I think that would be really cool, because then you could play it on all sorts of different platforms. Yeah, I think that would be pretty nifty, actually. And I want it to have a pretty small RAM footprint, so in order to keep that under control, I'm dynamically allocating all the memory I think I might need right at the start when I boot up the program. So if it's not going to work, you should know pretty quick. I think the base RAM size in DOSBox is 16 megabytes, so that should be more than plenty. And also just some shout outs. I have a really nice collection of DOS programming books. Probably the one that's helped me the most with this so far has been The Black Art of 3D Game Programming by Andre Lamothe. It's some really good stuff. You can get a copy of it on eBay for under $20. Mine didn't have the CD. So I'm probably gonna, if I need any of the sample source, I'll probably have to look it up online. Although not that it's going to help me much, because I think it uses either Turbo C or Visual C 1.0. So I'd have to translate it over to GCC's stuff anyways, because it uses some assembly. Yeah, here's my channel, which you should already know if you're watching this. This PDF's mostly for people looking at the PDF from GitHub. So hello to all of you on GitHub who are watching the video, and hello to all of you on YouTube that want to view the GitHub page. I'm not too good with making these videos. I hope to get better though. So where do we start? Well, we start with main.cpp. As is tradition. This is the way. If anybody's watching The Mandalorian, it's a great show. So we have a whole bunch of includes. Standard input output, dmpi.h. I'm not sure I need that one. Since we're not using any fancy DPMI stuff. Using string. So, and then here are my local includes, and then here are the things we need to get Lua up and off the ground. So I call system in it, but it's not really doing anything right now, but it will. So we call video in it. If I hit F12, we can follow it here. We don't need the near pointer enable because the server thing kind of takes care of that for us. But here we are setting up the video mode. We're allocating all the memory that we're going to need, and setting the pointers. So as we discovered in the last video, there is a base offset we need to keep in mind, the conventional base, so we can hit that low memory area. I think that's what part of what the DPMI server does is it makes it so we can still hit those things. We have a back buffer because we want to do memory copy and then wait for vsync, memory copy, then wait for vsync, and then that's how you get a consistent 60 frames a second. But I still need to add some code in here so we can read off the real-time clock that most DOS machines have. Yeah, that's very important, so we can have a even more consistent frame rate. I don't want to quite do variable frame rate, but if we have the opportunity to try and cap it at 60 frames per second, I'd like to do that. So here we have video cleanup. So that puts the text back to how it's supposed to look after you're done running the program. If you were running this on DOS, a lot of people would be very upset if you didn't do the cleanup, because that leaves their terminal in a weird state, and there's not really a good DOS command, I don't think, for setting it right. So clean up your stuff when you're done. One thing I'm not doing is I'm not clearing the tile memory or the font memory. So we'll add a little to-do in here and I'll take care of that later. Yeah, we'll need to fix that up. So, alright, that's video. We go back to main. We could probably move this over into sysinit, because the scripting is part of the system. So kind of what's going on here is almost all of the game is going to be done in Lua, and AOC is really kind of the engine. So depending on how much you're willing to change, you could make this do pretty much anything. There's nothing special about the code I'm writing that's like, hey, this is only for this particular style of game. That's all going to come down to the code. But what we do is we initialize the Lua state, and then we tell it to open the Lua libraries. That's for stuff like file I/O and keyboard input output. Even though we'll be supplying our own commands for that, the math library. So stuff that's much faster, and it saves me from having to do a whole lot of stuff on my own. So it's great that there's a Lua standard library that we can bring stuff in from. So load the file containing the script. So we're going to be looking for a main.lua in the scripts, and that's where things will kind of kick off. So if there's something wrong, we basically print out that error and then abort. So at this point the script's not executing yet, we've just loaded the file. Here we register the functions that Lua is going to be using. We're registering them globally. I think it would be kind of neat if I could register them in a Lua table or something, so that, you know, it'd be namespaced and whatever. It'd be a lot easier for the editor to pick up on, but I haven't done that. Clearly, they're just in the global namespace. That's fine. I mean, you're not gonna rename a whole bunch of things. So if you notice, there's special versions of each of the commands. They're basically wrappers for the Lua stuff. So originally I wanted to do JavaScript because I use JavaScript all the time for work, and it doesn't do, as strange as JavaScript can be, it's not as strange as Lua, because Lua is base 1 indexed instead of base 0. Lua, with JavaScript you have objects and arrays and functions and primitives. With Lua you have tables and primitives. Like, everything's a table, named or otherwise. A array in Lua is just a two-dimensional table where you have your key and your value, and the key starts at 1, 2, 3, 4, so on, instead of 0. Kind of unusual, if you ask me. There's other things I know you can do in JavaScript that you can't necessarily do in Lua. So I'm kind of disappointed I couldn't find a good interpreter that would work with MS-DOS still. So Lua it is, and there's plenty of example code and things if I need to borrow code. It's out there. So we're going to run the script, and if everything goes fine, we clean up and shut down. So that's kind of the main loop of our program. That's where all the magic happens. Alright, so let's look at some of the engine routines. So we'll start with input. We pull the keyboard using the scan codes. From what I've read, that's not necessarily a good idea because different countries and keyboards have different scan codes, so it's really the scan codes for my particular keyboard. So we might need to have a little calibration routine that runs at the start or something. I know there's a bunch of different ways to change how the keyboard works, so I'll probably look into changing that around. There's like an interrupt table. It's kind of like operating system level callbacks for like when the keyboard is activated and used. You can actually override the system callback and have it call code for your program instead of for the OS. So that might be the route we take. Right now it's very much one key at a time. It's not going to detect multiple key presses. So there's some options for how to do that differently. What would be really cool is if you could just kind of read the location in memory directly with like a peek or something like that. But from my understanding, there are some very good reasons to do the service interrupt way. Pulling the mouse is a lot easier. You just do that with a standard interrupt, and it's like that. So input.cpp. I'm not sure why I named these .cpp. I'm not using any classes. I think there are some C++ features I am taking advantage of, but I don't want to write just plain old straight C either. So let's see with C++ features, I guess you could say. Well, I'm not sure what features I'm actually taking advantage of. So pull a keyboard. I'm having this one self-initialize. So if not initialized, we're going to initialize the keyboard, and then we're going to call interrupt 16 and grab the registers off that. If there is keyboard input, then let's see, here we're actually clearing the keyboard buffer and then returning the key. So one thing I think I definitely need to do is I need to change I need to change up how I'm reading in the registers. I'm recycling them. I don't think I want to do that because I think I want a fresh copy. So like if I'm reusing it and the interrupt isn't setting AH to anything, it's just leaving it there, then I'm gonna have dirty info. So if it's using it but then not setting it, it's going to be what I originally set it to at 0, 1. So I need to change that around. Just lots of little small things just to make a better engine. But nothing that would be game breaking at this point because there's no game to break. Pull a mouse. Again, we're statically initializing it here. So interrupt 33 isn't actually part of 8086. It's like 8286 maybe. So here we need, instead of just the high ones, we're actually using word size registers. So we're setting AX, and then we read back from AX. And so we have we're passing buttons X and Y in as pointers, so that way I didn't have to invent a new structure just to hold everything. So we're setting the value of X to the output of CX, and we're dividing that by 2 because we're trying to fit the coordinates back into screen space. Then for Y, it's the same Y everywhere we go, so that's fine. And then buttons. 0 is nothing's pressed down, 1 is the left mouse button, 2 is the right mouse button, 3 is 1 and 2 pressed together, and then 4 is the middle button. So there's actually support for 3-button mice right out of the box. I don't think we'll use the 3rd button in this game, but it's kind of cool that it's there if we need it. So here we have the Lua bindings. Basically, how you communicate with Lua from C is you push stuff on and pop it off of a stack, and that stack is shared between the two. So here we're telling it, okay, we're pushing 1 number onto the stack, so we return 1. Here we are pulling the mouse, and then we're actually putting these values in a table, and that table has buttons, an X and a Y. So we're pushing these things, but we're only returning 1 because the thing we're returning is the table. So here is the code for Lua. I didn't write any of this. I do believe the license allows explicitly for statically linking it. If not, whoops. So there's a copyright notice in Lua.h. See copyright notice at the end of this file. permission granted free of charge to any person obtaining a copy of the software and associated documentation, blah, 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 without restriction, including the above copyright notice and this permission notice shall be included in all copies of substantial portions of the software. Alright, so I'm going to need to make a software.txt file just kind of explaining all the external libraries and stuff I'm using. Not a big deal, we'll get around to that. But yeah, we're using Lua, so it's kind of important. Here's main.lua. So I think we could probably get away with doing this. I just wanted to set some initial values because if it's undefined, it causes a problem, but I don't think that's a huge problem. So we get the mouse. Mouse is the name of the table, so we have mouse.x, mouse.y, and mouse.buttons. We're not using them here. Alright, so let's in sys.h and sys.cpp. Well, I'm adding some logging, because sometimes I'll get strange seg faults after changing something, and I'm not really sure what's going on, so logging just kind of lets me know where things are supposed to be. So, yeah, it's not very advanced logging. I'm not using var args or anything like that to try and figure out, like passing in, values to go with it. I'll add that eventually, but for now it's just, just some logging. So we have one right now. Okay, font loaded. Okay, great, awesome. But that helps me because this is running in DOSBox. I don't have debug tools unless I wanted to debug DOSBox itself, and then I wouldn't get anything useful because there wouldn't be any debug symbols that GDB could pick up on. I don't think. I'll have to look into that, but I think it wouldn't look like GDB would be expecting it to be because it's a DOS thing. Maybe there is a port of GDB for DOS that could actually be useful, but I'd want to do remote debugging over an IP address, so it's kind of out of the picture with DOS. I don't think DOSBox supports any networking, so we'll do logging for debugging. Alright, here's kind of the meat and potatoes, video.cpp. So these are the ports and memory locations for messing with the palette. This is code for handling bitmaps. I think I might move that to a different file just to kind of make things easier. Fskip, I didn't write this. This was part of the tutorial on David Brackeen's site for loading bitmaps, but it's pretty handy, so I'll leave it in here. Basically, you skip over so many bytes in a file. So, actually, I'm going to go to video context.h or video.h first before we do video.cpp. So, the idea, or kind of one of the limitations I'm putting on this project is that you're only going to have one tile sheet loaded at a time. So 64 by 64 by 8 by 8 is 512 by 512 pixels. That should be more than plenty. That's at least 320 by 200. So you could fit an entire screen worth of tiles in there. You could have every letter from the standard ASCII character set and more. We won't need that, so we won't do that. We'll do a custom tile set, and then we'll map letters to locations on the keyboard, or locations in the tile mapped image. Yeah. So what we have here is we have our video context. We have VGA, which is where the screen pointer is, the back buffer, tile memory, and font memory. We have video initialize, video cleanup, and swap buffers. Set pixel with XY in color, set tile pixel, row, column, XY in color. That's if you wanted to dynamically update the tiles. I'm not sure why you might want to do that, but it's doable. Draw tile, so given a row and column in the tile sheet, you can use that and set that and provide a transparent color. Probably almost always going to be 0. Set palette and get palette. Again, this is 8-bit color mode, so there's 256 colors you can pick from. Put stir. So this uses just the default BIOS font to put stuff on the screen. You generally want to only do this after you've swapped the buffers. Useful for debugging, but not very good for actually doing game stuff when you might want to do something where you might want to draw over the text. This also doesn't support transparency, so it's just whatever the foreground and background colors are set as. And then a function to load the tile set for a given path. And then here are the functions we're exposing to Lua. So go back here, load font. This is going to get rewritten. I'm just going to put the font in the tile set for now. Again, part of the problem I'm running into right now is different bitmap files having different palettes. So if you've got a font file with really only 2 colors, and those 2 colors are the exact same color in a tile set, well, then you're not going to see any text. At best, you're just going to see an empty blob. So this is just code to read in the bitmap. I'll just skip over that. Nothing much there. Yeah, initializing the video. I think I was showing you guys that enough. Video cleanup, set pixel. You know, if you just want to draw an individual pixel to the back buffer. Swap buffers, does a memory copy. Do a to-do to wait for VSync. Gotta get those 60 frames per second, yo. So this code here is what we use to set the palette. So we have out key, which I need to make a video over all the different ways you can communicate with hardware inside of DOS, because so far we've seen directly accessing the memory like we do with VGA, so we can draw. We've seen calling interrupts, which, you know, that's another way to do stuff. And now here we're doing output, which is there's ports, but not really. So we write the index of what we're going to change to the palette index, and then we write the palette data to the same port over and over. So think about it like you're writing to a virtual COM port, but that COM port's actually the VGA card, I guess. So So here we have set tile pixel, some crazy complicated math in there. Draw tile. So I'm actually going to have one that'll let you draw a range of tiles, because sometimes, like, we're going for a base sprite size of 8 pixels by 8 pixels, but you might have some 16 by 8 pixels, or some sprites, or some 16 by 8 sprites. So, you know, it'd be more efficient to go across the whole range and then down one row, whole range and then down one row. So, shall do that instead. Draw char, this is going to get ripped out because we're going to be handling drawing text from Lua. That's just going to be part of what Lua does. We'll give each character a row and column index and go from there. So that's going to get ripped out. Draw string, that's also going to get ripped out. So get palette. Again, we push, you know, what the index is that we want, but instead of output, we input. So just read that, read that, read that. If you kept reading that, that would go to the next in the series. So if you started at 1, you read red, green, and blue from 1, and then you read red, green, and blue again, that would be for index 2. Put string. So this is the one that uses the interrupts to write the text, kind of. So when you set AH and BH, you're basically saying, okay, we're going to move the cursor to this point in, you know, the character buffer, and then you use DH and DL to set the row in the column, and then you can print whatever you want. So that works as long as you don't care that you're not getting transparency, and you have to do it after you swap the buffer. So load tiles, this loads a bitmap of 512 by 512 directly into the memory. So you could call this function right in the middle of doing something, and you'd have an entirely different tile set, and the graphics would probably look like a corrupted NES sprite. So you'd probably want to only do that like between levels or something like that. But I'm kind of hoping for this game we can have everything in just one tile set. So, and then here are the Lua the Lua functions. So most of these are write only, coming from Lua, so we don't have to return anything back. Maybe if we did like a get pixel or something like that, but I don't think we're going to do that. So that's kind of the whole entire shebang. Things. What's this license? Oh, yeah, it's the license for Age of Chaos licensing it under MIT, so that way I can, you know, still have control over my own code. If you want to fork it and do something cool with it, that's awesome. If you feel like you can contribute something to it, that's cool too. You know, more than open to accepting contributions. I think that would be cool. It's a lot of code and stuff to write on my own. I don't have a whole awful lot of time to do this, so whatever would be nice. So yeah, that's just kind of my thoughts on Age of Chaos and where we are right now with things. I'm hoping future videos will be much shorter. This one's pretty long because I wanted to do a code review of everything from scratch. Going forward, we'll just be covering the deltas, like if I add a new function or if I actually make progress on the game part of this project. So yeah, thank you for watching. Like and subscribe, I guess. I'm hoping to put out at least one video a week, if not more. Especially now that I have my voice back, that I seem to be over this horrible code. Not code. Cold. So yeah, I hope you enjoyed it, and please tune in again next time.